Please welcome Valerie Leitner, Acting Director of the U.S. Department of Energy's Advanced Manufacturing Office, along with panelists Mike Horrell from Uptake, Jeff Kent with Procter & Gamble, Dragos Marginentu of Boeing Research, Steve Roweter of Goodyear, and Arjit Sengupta of Able.
Thanks for hanging in there for the last session of the XLab event. This one is going to focus on manufacturing. I'm Valerie Leitner, and I guess I want to mention first, you'll probably notice that Dragos didn't make it today. Unfortunately, he got the flu, and so he wasn't able to make it. Just the five of us here. But I'm Valerie Leitner, and I lead the Advanced Manufacturing Office in the Department of Energy. And the Department of Energy focuses on manufacturing because manufacturing uses 25% of the energy in the United States. And it's also really important to our economy. It represents 12% of the GDP. And in my office, what we do is we catalyze research and development and adoption of advanced manufacturing processes to enable both an improvement in energy productivity and also competitiveness of the manufacturing sector. And as we've been talking throughout this event, we do that by partnering with you. It's through public-private partnerships where we include industry partners with our national labs and universities that can take the technologies that are being developed and deploy those in their factories there in the United States today, or building new factories with new technologies in the United States. So manufacturing is a really broad and complex area. And so, I mean, particularly when you think about the whole manufacturing supply chain and their distribution networks. So with the introduction of the industrial Internet of Things, a lot of data is being collected now, and through increasing number of processes and throughout that manufacturing supply chain. And this, when you connect this data up with artificial intelligence and machine learning, it offers the opportunity to turn that data into action within those companies that ultimately optimizes manufacturing. Within our office, part of our portfolio includes a manufacturing demonstration facility at our lab at Oak Ridge, which is focused on additive manufacturing. And that facility has brought in dozens of additive manufacturing suppliers to have to try to optimize their technology, and also end users of additive manufacturing. And this is an area within our portfolio where machine learning and artificial intelligence is being applied. And the ultimate end goal of applying these technologies to additive manufacturing is that you could produce parts that are born qualified. So no post-processing testing to make sure that they meet the certification requirements. You would do all of that online while you're making the end product, the end component. So this is the kind of exciting opportunity that we're looking forward to hearing more about from our panelists about how they're using AI and machine learning both within their manufacturing facilities today and then opportunities they see for using this technology in the future. And so I'm just going to let each of our panelists talk about what their companies are doing in those two aspects, and then we'll have an opportunity for questions. I have a few questions, but while you're listening to them talk, think about questions that you might have. So we'll go ahead, Michael.
All right, thank you. So Mike Carell, I'm head of data science at Uptake. I also hold a PhD in statistics, so I've been in the AI and machine learning space for quite some time. I'll give you a little bit of background on Uptake and what we do. Industrial analytics company, what we do is build software that analyzes data that comes off of industrial machines to try to understand when those machines are failing, operating inefficiently, or otherwise unsafely. And so we help the owners and operators of those machines, again, do so just more efficiently and again, more safely. Examples of the industries that we are in. So we work on solar farms, wind turbines, locomotives, mining trucks, semi-trucks, and we're in the manufacturing space as well. So that's kind of the brief background on Uptake. I figure since I've been in the AI and machine learning world and now in the industrial analytics space, the perspective that I can give here is around, what's different or what are the particularities of industrial analytics compared to AI and machine learning, and then of course, like, what are even the kind of sub peculiarities about manufacturing as well. So just to give a high level of what the differences are. So in the industrial space, in the manufacturing space, the stakes, I believe, are much higher than you'll find in many other AI and machine learning applications. The cost of a prediction that stops your production line is much higher than the cost of, for example, classifying a cat as a dog. As one kind of brief example there. Two, I think that the nature of the data in manufacturing and the industrial space is significantly different in some respects. So getting data off of sensors, you do have a high density of data, but at the same time, if you're trying to complete a predictive maintenance type of application, the actual numbers of failures are actually quite low. So there's a balance of like very dense data in some respect, but very sparse data in other respects that can be challenging for practitioners. And then the last thing I'll say before handing it off here, with AI and machine learning applications, the temptation is to try to automate everything always at once. And I think especially in the manufacturing space where there are there's just tons of technical knowledge, tons of SMEs that are involved in the process as a whole, that one of the main goals of AI and machine learning really should be in enabling those experts to perform their jobs more effectively, more accurately, more efficiently, et cetera. So I guess part of this I'm saying is I think there's a crawl, walk, and run with the automation piece that comes with AI and machine learning, and a big part of that is just enabling the experts that exist today.
Okay,
great. So Valerie, thanks for the invite to participate in the panel and the event. It's been a great opportunity. First, I'll explain my role, and then I'll explain Procter & Gamble's endeavor in AI. My career's come full circle. I joined P&G 21 years ago. I came from the U.S. Air Force before that, working on smart weapons integration. So after 20 years, we came up with this concept of smart platforms to enable scale delivery of intelligence across manufacturing and our supply chain. So I feel a bit that I've come full circle. Relative to my role, I lead a team of data scientists, controls engineers, OT, IT, all working against these objectives of bringing intelligence to life to transform our manufacturing operations or our overall supply networks. As far as Procter & Gamble as a whole, I'm sure many of you know it's one of the world-leading consumer packaged goods businesses. We have huge scale operations around the world. We have over 360 operations with over 60,000 supply chain employees alone as a part of the 90,000 employees. Our endeavor into AI is broad-based. We've had support from the company to go after these strategies in areas that we've talked about this week. We intend to be a world leader in sustainable products. So the advanced materials discussion that occurred yesterday is resonating with me and how we should be participating in the advanced material development through AI. We're looking to also do sustainable operations through renewable energies in our plants, and we have large stated goals in that area, and we need AI to serve that. And then on an absolute business profit and loss basis, our large operations in supply chain or manufacturing need to operate at the highest productivity for asset efficiency. So as Michael was describing, we have huge opportunities to serve our operations in the plants, our distribution centers, to operate at the highest level of productivity, the highest level of quality, precision, and the cost of quality. And then my group's opportunity is to not just do invention. I think Gartner describes well that innovation can occur almost anywhere, but the problem is scaling it. Less than 20% of innovation in this area scales. So for Procter & Gamble, they invested in my team, my role, and its collaboration across the business to make sure that these innovations that we derive from the labs or derive from other partners are prepared to scale. And the term smart platform is, as GE described, a way to make it so that it can be used for multiple use cases over a scale infrastructure. And I'm glad to be here to talk more about it.
Steve Rowetter with Goodyear. I'm responsible for technology development. Basically, that means we are the upfront innovation engine that feeds the product development parts around the globe. That includes new compounds, new reinforcement materials, new design methods, new constructions, new mold features, new manufacturing capability. And most critical and relevant today is the new simulation, new modeling, and new methods of developing products. We've had a long-standing relationship, several decades now, with Sandia National Labs to develop physics-based modeling to simulate the performance of tires, and it's not an easy problem to solve. Billions of degrees of freedom and a lot of difficult material properties to account for in the physics. And now more and more we are adding data-driven methods to that capability. I got in the car the other day to come here, and my son said, "Where are you going?" I said, "I'm going to an innovation XLab, artificial intelligence." And he said, "What does Goodyear have to do with artificial intelligence?" So I had to explain. We use machine learning methods to speed the industrialization of new products, to learn on processes like rubber extrusion. We use it for multi-performance optimization in product development, where historically it's been rule-based or programmed empirical-based information, and more we're adding access to data sets that exist and creating the learning and adding to the robustness of those prediction methods. Tires are a complex problem, as I said. They have a lot of trade-offs. What you do to get better wet traction is not necessarily what you get for better tread wear. And so you're constantly balancing trade-offs in materials design, and the manufacturing process and the way that material is prepared can affect those trade-offs. So again, we look at manufacturing process modeling tools and the use of machine learning to enhance that. Our AI expertise grew from our manufacturing process modeling efforts working with Sandia, and it continues to expand across the organization. So again, thank you.
Hi, I'm Orijit Sengupta. I'm the founder and CEO of Able. Think of us more of a mission than a company, because we are trying to make sure that AI goes the path of things like the internet, where anybody can use a technology, as opposed to something that stays in labs and only extremely trained people can leverage it, right? My background, before this I started a company called BeyondCore that became part of Salesforce Einstein. It was one of the earlier AI companies. Studied AI at Stanford from the last generation that actually saw the whole nuclear winter happen. So it was kind of interesting to learn from people like Ed Feigenbaum who had been through that process. So they never hyped up AI. And essentially, I one day counted that I had done about 1,000 AI projects where I took data from a customer, went through, created a model, and then had that really uncomfortable conversation where you're trying to explain to the business user what the heck the AI has learned. And you figure out how important domain knowledge is when you just try to do anything. So I ended up writing a book called AI is a Waste of Money, where I took all the things that broke in AI and put it together. But I'll tell you one story which really brings it back to the point of why AI can be a waste of money most of the time. I would have customers tell me, your AI is never wrong and it's completely useless. I'm like, what do you mean the AI is never wrong and it's completely useless? They're like, look, I need to sell to 50 customers a month. Your AI tells me to go after these 5 customers. Those 5 customers are fantastic customers. They're great. If I only sold to those 5 customers, I'd be out of business. What has happened there is there's a concept of false positive, false negative, right? So basically, I predict something is going to happen, and I'm wrong. I predict something won't happen, and I'm wrong. There are costs associated with that. In business, in manufacturing and operations, we always have this idea of balancing various costs, balancing operational capacity. As we started obsessing with AI, we almost started acting like the rules of physics don't apply anymore, right? If you actually consider what is the benefit of a sale, what is the benefit of preventing a product defect compared to what's the cost of unnecessarily replacing a part, you're going to end up with a different balance for your AI than if you just try to go for accuracy. So imagine a very simple example, 10% of your customers buy, and an AI is trying to be accurate. What's it going to do? It's going to tell you, don't sell to most people. Because if it tells you a customer won't buy, it has 9 ways of getting it right. If it tells you a customer will buy, it has only 1 way of getting it right. So if you're just going for simple accuracy, you end up with a ridiculously conservative AI. So I think it's very important to bring this balance back to the world of AI. All the things we learned in operations management didn't go out the window just because we got predictions right. You got to have the operational constraints and you got to have resourcing come together. The second part of this, I really believe that the internet revolution started with the Netscape browser when anybody could use it. The PC revolution started with the Mac when anybody could use it. The AI revolution is not a revolution as long as it requires extremely experienced people in a specialized function to empower business. So we do these kind of really irritating things for certain people. We ran this contest at Berkeley where we took a bunch of high school kids, history majors and MBAs, and put them up against expert data scientists. Give them the same problem, and after 2 hours, the high school kids beat the data scientists, right? Because we have somehow started believing that all that matters is how well you can code. All that happened was the high school kids were more curious, and they thought through the problem and thought of the cost-benefit trade-offs, and then they used automated tools. But all the programming skills of the data scientist was balanced by simple curiosity in the part of a high school kid. And that's how we come at this problem, is you need to empower everyone in an organization, not just a specialized few.
So building on that last story, talking about high school students, just before the panel, Steve and Jeff and I learned that we all have kids that are in college. And so, so we've been thinking about, potential opportunities for workforce for our children. But I'll ask to the panel in terms of using AI and machine learning in manufacturing, what needs to be done to prepare the workforce to use those technologies both today and in the future? And I'll start with you, Orjit.
So the interesting thing about AI is it's easier to teach AI to speak business and operations than to teach business and operations people to speak AI. So the first phase of any new technology, you come at it with a band-aid solution, which is training. Let's go teach people how to write code. Let's go teach people a specific platform. But AI technology is evolving faster than Moore's law. So think of the people who were writing code to a specific chip. They always did worse than the code that was portable because the next generation of chip was so much better that the program got better, right? we are making the mistake of thinking people need to learn the underlying tools of how to create AI. What they need to learn is how to be curious about their businesses, understand the fundamental principles of how should I pick a good AI project? Is it predictable? Am I going after revenue, then cost, then risk? Where do I get the data? What kind of data could potentially be useful? These are questions that are related to being curious about your business. The actual tooling of it, I fundamentally believe, will be and is already being automated, because that's the only way to make it scale. That's the only way you get it to everyone. Otherwise, the information disparity that it will cause is going to be worse than the Gini index. It's going to have this huge haves and then many, many complete have-nots. And I don't think that's the world we want to be in.
And I think, Steve, you had some thoughts in that regard.
Yeah, I would say look at it two ways. The future workforce, we encourage with STEM activities in our community, high schools and so on, the sciences and math and so on. And there's probably more to be done there to educate on what AI is. A child born today, everything's automatically already connected. But when we were born, nothing was connected, right? Mm-hmm. So we've got to encourage them to think about what that means and what they can do with that. For the workforce that exists right now, we have a core group of data science experts, if you will, within Goodyear, supporting global operations. And roughly 1/3 of that group is people from within Goodyear that have moved between departments. Maybe they came from the quality organization, maybe they came from product development. And then we've moved data science experts from that group out into their organizations. So I think mixing that cross-functional expertise helps solve that problem of getting people to speak the two languages going forward.
So what I would add to what Steve said is artificial intelligence, we said yesterday, is a very wide term, right? And in my role, we've been recognizing both the technology stack and then the data stack. So obviously the frosting on this cake is getting to do advanced machine learning with a very healthy data set. But inevitably in the workforce, we're going to have a proliferation of other specialties, from data modeling and data engineering to those who are in sensors and instrumentation, all the way to the data science. So I feel like in the workforce development, and we're seeing it at Procter & Gamble, certainly how we use our very scarce data scientists to solve the toughest problems and to build the next generation of what we're calling citizen data scientists who live in their subject matter expertise and understand the problems to be solved. They also have a whole nother ecosystem of data engineering and data sourcing that we're also trying to be sufficient in. Because inevitably we're doing these innovations, we're solving problems with AI and machine learning, and then we have this large question, how are we going to maintain that over the life cycle of these capital assets or the work system? And we're realizing there's roles and skills and opportunities in maintaining and operating these models in a DevOps model as much as it was to do the innovation. So I think our answer at Procter & Gamble is very much like Goodyear. We want to be thoughtful how we keep data scientists in the business workflows, solving business problems, while we have advanced data scientists doing the progressive new forms with the laboratories. Yet there's another whole ecosystem around data design, data management that is also emerging that maybe isn't as sexy as the artificial intelligence, but you can't really do AI unless that's healthy. Mm-hmm. So we find that endeavor exciting for our employees. We are seeing upskilling, we're seeing new hiring practices. But the real challenge for Procter & Gamble is once you hire the talent, how do you keep them and how do you keep them happy to stay? So, it's not just finding them, it's also getting them in the right roles and the right projects, and feeling that working on a consumer product for sustainability or energy or advanced materials or just manufacturing is exciting. So we're working on all those different dimensions, and I think what was said earlier applies to us as well.
Michael, did you have anything further to?
Yeah, so I might break that question down in kind of one main way. There are data scientists. How do we train the data scientists to be effective in this space? And then there are the end users who are consuming these predictions. For the data scientists, I think it was mentioned that, pair them up with the citizen data scientist or the SME. I totally agree with that. I'll also say that a lot of data scientists there's a skill in terms of learning how to listen to an SME to build a better model. So how does the data scientist still own their model without, offloading all the decisions to an SME or without, closing them off? So there's definitely a skill for the data scientist to learn, to truly listen to, what the experts are saying, compare that to the realities of the data that exists, and then coming up with a really quality model at the end of the day. And then on the users or SME side, I would say that there's, in our experience, we've found users who already consume a ton of data today, are really hungry for like the next prediction or the next thing. Those users are ready and ready for the coming AI. But we also found users that, in order to manage their production line or factories or whatever it is, that literally go around and touch machines, feel the vibration, smell like areas of the factory just to understand, are there leaks going on, et cetera. And for them, data isn't part of their day-to-day just yet. So for them, it will be a more kind of paradigm shift to like being more comfortable with data, consuming it day-to-day, being able to ask and answer good questions kind of on their own. So those are the various gaps that I see.
Great. So this next question I'm going to address to Jeff and Steve, and that is, what is currently holding back the use of AI and machine learning in manufacturing across that supply chain?
Well, there, maybe I'll start. As you can imagine, at a company the size of P&G, we can be a bit siloed and compartmentalized. We also, for years, relied on our IT organization or other scale organizations to bring solutions that would then be employed in manufacturing and supply. The reality of AI is this is the ultimate team sport. Whether it's where the data comes from, the subject matter expertise, the infrastructure, or the business value, these are much more collaborative projects. So we're having to make the very needed transition to break down silos among IT, data, modeling and simulation, manufacturing, engineering, and work on these projects together. So, we feel like the company recognizes this now. We're creating centers of excellence that are multi-discipline, multifunctional, with support at the highest levels of the company. Now we got to get the people at the ground level to be empowered to work on these together. Additionally, I said it earlier, I still think we're underestimating the obligation on data management, data procurement, data harmonization, data contextualization, how that is thought of from the beginning of our products, initiatives, and equipment. My role, unfortunately, when I first got the job a year and a half ago, is to go after brownfield. How do you make equipment that's already running in a plant smarter, more intelligent, more productive? It's very difficult because they're very busy doing what they're doing. And they may be skeptical that an existing equipment platform can be made more effective. So now we're combining our brownfield work with any new initiative and building in the intelligence from the beginning part of the product, process, material, equipment definition. It's exciting and fun, and even that you can't do everything. So my long-winded answer is we have to, in a corporate level, break down silos that don't enable you to work on a digital project that doesn't have any boundaries. Digital use cases don't respect corporate silos and responsibilities. It has to be democratized and everyone has to participate, and then companies have to offer the tools, techniques, and as was said earlier, democratization of data science to make it possible. So we're in that journey. We've got the declaration, we've got roles like mine and others to make this happen, and we can use the labs to bring some of our toughest problems while we work on our own internal problems. Okay?
I would agree with the silo comment as well for us. The two biggest things I hear that are holding us back are the data quality and the data connectivity, especially in the manufacturing organization. Yes, we've got new factories, we've got upgraded older factories, if you will, but the data isn't necessarily all tied together in a manner that makes the use of AI easy. I started at Goodyear over 30 years ago. We used to make physical prototypes of a new idea, a new design, a new feature, and then test the heck out of them. And then we sat there and the young guys would say, I wonder if we can model this, right? Stopping distance under a wet traction condition, noise in a pass-by situation. Is it possible to generate physical models based on that? And over the course of my career, we've been very successful at doing that. And it feels like this AI is somewhat the same thing, right? It's like finite element. Did you believe it? Did you trust it? Did you know where it came from? What was in it? It's the same basic thing all over again that we have to go through to encourage that use.
Great. Any other thoughts?
So to the silo point, one of the issues, you also brought this up, it's not a data science problem, it's a data engineering, DevOps problem. And unless, one of the most important things about AI is it's always iterative. In fact, the more effective an AI, the moment you deploy it, it'll change user behavior, it'll change customer, competitor behavior. So the more effective an AI, the more quickly it goes out of date. And this is the thing people forget. So AI deployment has to be iterative. You get something good enough, get it out there, learn, and iterate, iterate, iterate. So if you don't have that entire cycle figured out, from raw data to data science to DevOps to monitoring and recycle, you're not going to get results.
Yes, yes. I'm fortunate to get to work in Cincinnati near GE Aviation, and we have peer connects, and that was the biggest striking recognition from GE Aviation was the shift of engineering from building a capital asset that worked at high efficiency under warranty to a whole full life cycle. And we heard it earlier of the digital twin and how the AI model or machine learning model is never complete. It is never done. And so for sequential engineering and digital manufacturing processes, that can either be exciting or intimidating as you define the roles in your team. An engineer today will not be only where they deliver and commission in return to the next initiative. There'll be some of that, but I imagine many of the engineers will be in direct, intimate partnership with the site by which they delivered that asset. That's a big mind shift, and then the tools to do so. I think some of the differentiating technologies are going to come not just from the AI, but who does the data modeling throughout the life cycle of those models, right? And so we're seeking from the labs and from the industry who does that best. So,
great, great. So the next question I'll at least let Michael you start with, and that is, with the implementation of artificial intelligence and machine learning within manufacturing, does that bring with it cyber vulnerabilities?
Yeah, it's a good question. And I think the short answer is yes. Like anytime you have more sensors and potentially computers that are making decisions and taking actions like based on the data of those sensors, there's opportunities for vulnerabilities. Now I will say that, at least in my view, some of that, like sensors have been around for a long time. People have been making decisions based on data off those sensors for a long time. So I do think that part of that problem is, kind of the same story, just more of it. So I think that's part of it. And I think another interesting side of the kind of cyber vulnerabilities piece here is that AI and machine learning, our experience is that you can even use that to find the hacks, potentially close things off before it gets bad. Early on we had a client where we looked at data on specific hacks on devices that necessarily had to be kind of out in public. And if you look at the data, it's for this particular example, it was very easy to see that, something bad was happening here. So I will say that while there are additional probably vulnerabilities, there might even be opportunities to head off certain other vulnerabilities.
Yeah, I mean, I would add to that as well. I think the power of AI and machine learning is we can be so much more vigilant about the role that a sensor plays in an architecture. Right or wrong, sensors in discrete manufacturing, maybe less so in process, we're kind of put in and forget about them other than under some maintenance strategy or some clean inspect. I think the reality is if they're connected, they're part of the larger data model, there are going to be more thoughtful ways to check their resilience, check how vigilant you are in watching the interaction. So I'm with Michael. I think it's a part of our strategy to make sure our designs are resilient against cybersecurity threats. It is not all hardware-based. It's not all isolation. I think using isolation where appropriate, but also using the connectivity and the power of your data model to see the threats or see the inactivity that is an anomaly is probably the way to answer that question for us.
Yeah, I wasn't involved in the decision to upload data to the cloud a while ago, but yes, that was a tough one for a company like Goodyear, you can imagine. But we did it, and I think we decided that the potential return and the upside far outweighs the risks, and there's ways to address that risk. But yes, I agree, it's a concern.
I think we have covered this enough, but again, people are taking different approaches to it. Like when you said you move the data to the cloud, you probably don't want to make 50 copies of it in 50 clouds. So people are coming up with techniques where you move the AI to the data as opposed to the data to the AI. So the customer's data is never exposed to the vendor. The final model is never exposed to the vendor. The customer owns the data and the model. So there are things being done to reduce the risks that people were concerned about when they first started.
Great. Now I have a couple more questions, but I'll open it up to the audience if anyone has questions. Come up to the mic and let us know who you are.
Hi, I'm Misha Wilson from Ginkgo Bioworks. My question is for those of you folks with supply chain models for your manufacturing. How are your supply chain models, and are they starting to think about the impacts of climate change on those supply chains?
So I guess I'll start. We have a new product supply officer, Julio Nemeth, and his big emphasis in coming into the new role is resilience. And so resilience against any of the transient effects that affect the supply chain. So we're certainly looking at environmental effects. We've been affected by numerous natural events over the last 4 to 5 years, and at the size of our supply chain operation, we're certainly looking at that and looking at how the data from all the different approaches to weather forecasting, whatever works on our business continuity plan, and how to optimize our resiliency is the term for us inside of our supply chain. So we're looking at both dedicated specific models in regions and then a comprehensive model of each of our different SKUs and each of our different business strategies for our products. So absolutely, we're looking for partners. We may even have some work with the labs where we look at how to deal with it, because it's not an easy problem. To look at a comprehensive supply chain model and deal with the computation, you do need high performance computing. So we certainly believe it's important as a term of resiliency, both in a regional aspect or on a global basis. So we certainly agree with you, and we are working in that space.
Other thoughts?
Hello, Greg Shannon from Carnegie Mellon. DevOps was mentioned a number of times, and I'm curious how you see that as part of a cultural transformation in manufacturing, because there's this paradigm of I buy a piece of equipment, I install it, it works for 20 years, and now if you want to incorporate AI, now you're continuing to change the configuration and sensorize and connect it as new technologies come up. Can you talk about how you see that transforming industry, how that's going to, and where you've seen success, where you've seen challenges?
Steve or anyone?
I can take it if you want. DevOps comes into so many different places, right? Let's take a few easy examples. Once you start deploying models, you figured out that the cost of a deployed model is higher than the cost of training a model, which most people don't realize. When Amazon first started talking about it, people thought they were crazy. Now, so what do? You don't keep servers spinning immediately. You want to go to something like serverless. Well, many DevOps people don't have the skills to know how to do serverless properly, right? Let's take it from a different perspective. You want to run a big data set. What do we do in traditional DevOps? You bring up a Spark cluster, and now the data scientist is going to work on it. Well, the DevOps guy has no idea when the data scientist is done. So it just keeps running for 3 months until somebody in IT starts screaming, why are we spending so much money? And then somebody figures out that it was not needed. How do you solve that in DevOps? Well, you want the server to come up for 3 minutes while the model is being trained. All the fact needs to be written down to a repository, and all the Spark ML servers should come right back down. The way to do this is either by training people to how to rethink DevOps in the world where the world has fundamentally changed over the last 2-3 years, right? How do you rethink DevOps with that? I'll give you another really funny one, which I find most DevOps people don't understand now. All through computer science, read and write access came together, right? If you had write access, you had read access. Well, that's not true anymore. That fundamentally changes how you can do DevOps, but most people haven't rethought how do you do that. That's why I was saying you can move the model to the data without getting access to the data. You do it by having write access, not read access. So you gotta rethink what we thought of in the world of DevOps in light of AI, and you have to automate the heck out of it. It's actually not just about retooling, it is about automating DevOps itself as much as possible.
So my addition to this is for industries who have made the leap to providing intelligence as a service, they couldn't do so without a model for DevOps. But for, you say, a manufacturing company like Procter & Gamble and others who are, you could argue, my role is to sell to my plant managers equipment and how it performs, we still have a ways to go. And I would argue the best opportunity is to bring it with our new equipment platforms, our new products and new processes, and be explicit with our manufacturing partners in P&G that this is what's coming and this is how your quality is going to be performed. This is how your maintenance is going to be triggered. This is how you're going to maintain your lines. I have a term, operators as pilots. This is how your operators are going to interact with this intelligence. For the existing brownfield, we will do this where we have the greatest risk, wherever we have quality that means the most to the consumer, or we have the greatest productivity benefit or the greatest benefit, and we'll be explicit about the roles that need to complement what was traditional engineering that was stage gate. So we still have a ways to go, and I can promise you there's a lot of education. Even the term DevOps would be a very small percentage of a plant manager's understanding of how intelligence will need it. Today they think they get IT systems, OT systems, they get commissioned, and then it's their job to run it. What we want them to understand in the future is it's their job to partner with the intelligence community inside of the company to maintain those models and have them continually improve. And the one thing that P&G has an advantage is we have something called the integrated work system, which its whole premise is continuous improvement and ownership. So I feel like I have a chance in Procter & Gamble as a part of it to introduce DevOps as part of how digital data and machine learning models will be maintained as a part of a continuous improvement culture. They're already obligated to do so, they're just doing so in maybe a less progressive world.
Are there other questions here?
Hi, Chris Tassoni, Slack National Lab. So I'm curious, a lot of industries and enterprise customers seem really comfortable with the B2B transaction to people doing ML development or AI development for them. And my question is, what are the ways that the national labs could be doing things that would make it a more attractive place, because the types of data that we can help augment, maybe the data set that you guys have, would require somewhere to be a shared data repository. And I guess, like, how do we, from your guys' perspective, like, what are the roadblocks to having an interaction more like you might have with your fellow panelists?
So I have a thought. I don't know, I feel like I'm dominating, but so we talked about materials, right? Characterizing materials, both to build advanced materials or to characterize the materials we have. The observation that I have in our industry, in our enterprise data, is we still struggle with the characterization of materials that ultimately we run and process to make products. So I think there is this opportunity, whether it's the definition of the data model for advanced machine learning or AI, to build new materials, or to just characterize the materials that we're using today, and the ability to transfer that data model throughout the supply chain would be hugely breakthrough. Breakthrough for our consumers, because we get better products, breakthrough for our suppliers who are providing those products, and then breakthroughs for us as we do the transformations. I think the weakest part of our endeavor on quality and productivity and maintenance is the material data model is still a bit a black box. We still get COAs, we still get data, but it's still averages and aggregates. I don't want to work in averages and aggregates. I want to work in data models that represent the power of big data. So to me, from what we talked yesterday, what are the ways that we would represent material characterization in a way that can be agnostic of discipline, but allow us to see materials for what they are? That's at least my interest.
I would agree 100%. Just help develop the data standards or the data models, gather up data that can be used like outside of the various silos that might exist, And what was the last piece? But yeah, develop the standards, gather up the data. Oh, I think, and then like help define the important questions as well, because having all the data in one place is great, but you're not going to kind of centralize, I think, some of the brain power without saying, hey, here are the core questions.
Any other questions from the audience? If not, I had one, maybe two others, but Jeff, you alluded to this a little bit earlier, but what kind of support are you getting from your leadership to implement AI and machine learning within manufacturing?
So I think at Procter & Gamble, there's great recognition that we're, as I said, in the business to improve the lives of our consumers everywhere in the world, and there's some big challenges. Additionally, it's a very competitive industry, right? And there's a lot of changes that are happening economically, social economics that allow us to, or expect us to evolve and transform. So typically we would do that through first principle science, chemistry, biology, and we're still leading in that, but we realize those fields, the fields of sustainability, the fields of being more productive, the fields of serving customers in 24 hours require supply chains and science that is beyond just the typical scientist. We need the power of AI to inform them. So at a corporate level, we've created Center of Excellence, among some others, that centers around enterprise data and analytics. And then once that's done, those expectations are funneling down to the other parts of the company to apply data and analytics to solving their big strategies. And so then, we're trying to inspire the working level. And so the big challenge at P&G is you have this great support from David Taylor and the C-suite across the disciplines. We have empowered employees who want to make a difference. And now the challenge is, and the term came up a few weeks ago, the frozen middle of a corporation, right? You have this great strategy, and they think it's going to happen because they've declared it. And you have the new employees who think it's possible because they haven't been jaded yet. And then the frozen middle. So I think the challenge at P&G is we do have senior leadership support. We do have roles like mine, which, by the way, I think I have the best role in the company. We have good, amazing employees. We've got to somehow unfreeze the middle folks who maybe are still skeptical or aren't really building the infrastructure or the possibilities for the jobs to be done and the problems. So, but I am encouraged. It's the first time in my career that I see really clear strategy in this space. Really good funding and investment, really good ability to understand we're going to fail as much as we're going to succeed, which is a part of the learning process, and really inspired talent that calls me daily to be a part of this mission. So,
great. Portia, did you have something to add?
Yeah, so I actually worry that CEOs love AI so much right now, because I was talking to this Fortune 500 CEO, and the entire time he was talking about what he heard at Davos and why he needed to do AI. And this is somebody I had talked to before, and I reminded him that he was complaining in that same conversation about how he got no ROI out of Hadoop. Because basically what my fear always is, senior execs hear a terminology, don't know all the consequences, get excited, want to invest. Then people come up with big projects because they want to have the biggest project possible. And then those projects, one or two of them fail. And suddenly people start saying, oh, this AI thing is not ready for prime time, right? So what I always try to get people to do is, how can you do many small projects instead of one big humongous project? And how can you suck the execs into the project, right? So there's a company called Mero Sewing Company. It was 1838 is when it was established. So we got the CEO of the company to start analyzing data himself, because we were like, hey, you love AI, do it yourself. And the guy actually went in and figured out, and he took out his data from Salesforce and created an AI. He found $3 million of value. I kid you not, he found $3 million of value. But what that did also is it changed his mind from this AI thing is something cool that I don't have a sense of, because he went through that process of what did the data need to look like, what was the data cleansing stuff, and he was able to do it himself. Now he's thinking about his entire business with AI front and center. From what investments the company makes to how do you set up operations. But in that one project, the guy went from I love AI to, oh shoot, I can do it myself. now I know what is possible in my organization. So let's make it real. If it stays at this theoretical thing, the exec support will very quickly sour when you have a first couple of failures.
Yeah,
Great.
I'll add on a little
Okay.
bit there. Yeah, I would agree as well. It's what the shiny object in AI and machine learning isn't the shiniest object right now. And I also think that there are a lot of big wins in terms of applying AI and machine learning in the industrial space that are not that are not like huge headliners. There's the data you'll have coming from sensors, and then I think there's a layer of just added measurement that AI and machine learning can add to that data that will make it that will enable the bigger kind of headliner applications. But I do think that there's a ton of value just in measuring things more closely. That again, maybe the CEO won't be excited about, but just like it's a needed layer in kind of the AI journey.
Okay, we have about like a minute to wrap up. So any like very brief closing thoughts, Michael?
Well, let's see, what else do I have? Nothing specific right now. Maybe come back.
Okay, maybe I'll start with Horjeet then and come back to you.
So in the conversations I've had yesterday and today, what stuck out to me was many of the lab researchers came and said, we have this great model, we think it's better than TensorFlow, we don't know what the use cases are, right? We need to figure out some way to partner where you guys take these great models you're building, get it into a platform where other people can actually use it, try it simply, experiment with it, find use cases, like let other people discover the use cases. It doesn't have to be you discover the use case. If you explain the characteristics of the model and make it easy for people to try, maybe it'll be pull rather than you trying to push it or throwing it over the wall.
Steve?
Yeah, we've got a great partnership with Sandia, like I mentioned, and I think that's given us insight into ways to approach some of these complex problems. We've got support from the C-level top down throughout the organization. I think it's just a matter of brute force putting the horsepower on it to take it forward across the organization right now. So.
Yeah, and Procter & Gamble's had great success with first principles science modeling and reliability engineering. What I took away this week, though, is there's distinct opportunity for us to work on more targeted measurement and sensing against some of our material characterization and others. So you can expect that Valerie will be partnering on advanced manufacturing and SESME and other things, as well as some more targeted work and use of the laboratory. So thanks for the invite, and it was a very great forum.
Yeah, sure. So yeah, I'd say probably the most important things is the data governance. Get all your data in one place so you can enable the decisions to be made in the right way. Embrace the simpler analytics that helps improve their interpretability and helps build trust in those analytics. Yeah, I think that's it.
And I'm going to put out a pitch for Manufacturing Day. So tomorrow is Manufacturing Day. It's the first Friday in October every year. So if you don't know what it is, look it up online and at least participate in a webinar or something to learn something new about manufacturing. So thank you, everyone.